Have you ever wondered if electric vehicles are really making a difference in the air we breathe? We hear a lot about how electric vehicles are better for the environment, but we want to dig deeper. Our research asks a simple but important question. Are states in the US that added to most electric cars between 2016 and 2021 actually seeing cleaner air compared to states that didn't? But we also know that it's not just about the number of electric vehicles. So we looked at other factors like how crowded a place is and what industrial activity it has to see how they might affect the results.
Electric vehicles, also known as EVs, have gone from futuristic to mainstream, promoted as a cleaner alternative. Sales rose 35% from 2022 to 2023, and California aims for all zero emissions by 2035 to reduce pollution and fight climate change. Research supports the benefits. One study in Nature Sustainability linked EV growth to lower nitrogen dioxide levels. Another from USC found cleaner air and fewer asthma ER visits in California zip codes with more EVs. Still, some studies may miss key factors like population density or industrial activity. In places with lots of factories or people, EVs might not have as big an impact, or maybe they still do. So what are we expecting to find? Our main hypothesis is that states with the biggest increase in electric vehicle sales from 2016 to 2025 will also see the biggest drop in air pollution levels over the same period. Our logic is that electric vehicles don't have tailpipe emissions, so replacing gas-powered cars with electric ones should lead to cleaner air, especially in cities where traffic is one of the main sources of pollution. We also have a second part to our hypothesis. We think this connection will be even stronger in cities that have less industrial activity. In other words, when there's not a lot of pollution coming from factories of heavy industry, the benefits of switching to electric cars should be more noticeable.
To explore the link between electric vehicles and air pollution, we use two main data sets. First, we use the U.S. Alternative Fuel Vehicle Registration Dataset, which shows observations from over 400 electric and other clean vehicles that were registered in each state from 2016 to 2023. It includes types like fully electric cars, plug-in hybrids, regular hybrids, and vehicles using fuels like hydrogen or biodiesel. We cleaned the data by removing national summaries and fixing number formats. This helped us track trends over time and compare adoption across states and fuel types. Second, we used a U.S. CO2 emissions dataset that records carbon dioxide emissions from across states from 1970 and onward. This dataset has over 2,500 observations and breaks emissions down by year, state, and source, like transportation or industry. For our study, we focused on emissions during the years when EVs were growing in popularity. To explore the link between EV adoption and air pollution, we merged two datasets to track vehicle trends alongside emissions over time. This lets us analyze how rising EV numbers relate to changes in transportation-related carbon emissions, controlling for state, year, and fuel type.
To better understand the overall patterns, we visualized EV adoption and CO2 emissions separately over time. In the first graph, we see national trends in EV numbers from 2016 to 2023. EVs have grown the fastest, especially in the recent years. Plug-in hybrids and traditional hybrids also increased, but at a slower pace. This shows a clear shift towards cleaner transportation options, especially as people and cities embraced EVs. In the second graph, we looked at national CO2 emissions from 1970 to 2020. Emissions increased for several decades, peaking around 2007. Since then, there has been a general decline. There's been a noticeable drop around 2020, likely due to the COVID-19 pandemic, which reduced travel and industrial activity. But even before 2020, emissions were trending downward. What's clear is that EVs are increasing steadily, while emissions are more complex, influenced by many factors beyond transportation, like energy production and industrial activity.
After exploring electric vehicle adoption emissions separately, we moved on to see if rising EV numbers are linked to drops in CO2 emissions. To do this, we combined the data from all U.S. states and aggregated it by year. We focused on both total CO2 emissions and transportation-specific CO2 emissions, since those are the areas most likely to be impacted by changes in how people drive. We then were able to calculate air relations and visualize any patterns that might suggest a connection between the two. In the EV adoption versus total CO2 emissions plot, what we found is that there's no strong linear connection between the two. While there's a general trend where emissions seem to go down as more EVs are on the road, the data is quite scattered. There is also one major outlier, around 1 million electric vehicles and just 4,600 metric tons of CO2. That dip is most likely from 2020, where pandemic lockdowns drastically reduced travel and industrial activity. So the drop in emissions that year wasn't due to EVs alone, it was part of a much bigger global disruption. Overall, even though the correlation is negative, meaning more EVs tend to line up with less CO2, the relationship is weak. The yearly EV adoption and CO2 emissions over time plot shows a similar story of the EV increase, CO2 fluctuations, and pandemic outlier.
Our results show that EV use is rising, while carbon dioxide emissions show more mixed patterns. When we look at both together, we saw a slight trend. More EVs often lined up with lower emissions, but the relationship wasn't strong. This suggests that EV can help reduce pollution, but their impact also depends on other factors like industry and major events. Overall, EV adoption plays a role in cleaner air, but is part of a larger system.